السلام عليكم ورحمة الله وبركاته. دكتور نضال الصالحي, Faculty of Business, University of Petra. We will continue with our Chapter 5, Design of Goods and Services. We stopped here last meeting. Today, as I promised you at the end of last lecture, that we will continue with the issues for product design. What are the issues that the management or the company or the operations management in particular should take care of in order to have the right design, let's say, an effective and efficient design for their products. The first issue is robust design, and this is the last thing that we have talked about last lecture. Modular design, computer-aided design, CAD system, computer-aided manufacturing, which is the CAM, and the value analysis. Let's start with them one by one. The first one is robust design, which is the first issue. Product is designed so that small variations in production or assembly do not adversely affect the product, which means if there is a little variation, we have to design our product in a way that if there is a little variation in the product, it will not affect the product as a whole. Which means, for example, if we'll take an example, for example, the engine of the car. If you are designing and producing a certain part for the engine of the car, and it has a length. Now this length, if it will be less or more by very small variations, it may or it should not affect the whole product at itself. There should be an allowance, in other words. This is the way that we said that it's a robust design. Typically results in lower cost and higher quality. Robust design, if we will have it on the right way, it will result in a lower cost. Why? Because, as I told you, if there is a small variation in some parts of the product, it will not affect the whole product. Then your cost will be less. At the same time, you will have a higher quality because it will not affect the performance of the product. The second issue that we have to take care of as an operation management, which is the modular design. Modular design. Products design in easily segment components, which means we try always to design our products in a way that it will be in small, let's say, or in segmented components in order to have it easily assembly. Example here, very good example, IKEA. Now IKEA, they have furniture which in small components which the customer can easily buy, and of course it is light and environmentally friendly with the environment, and customers, they can assemble or make assembly for their furniture at their home by themselves. Adds also, now if you have your product in segmented components, then it will add flexibility for both, for our production, our manufacturing and our operations, in manufacturing, and at the same time in marketing also. Again, IKEA, it's easy to market furniture, and you can make just easily like shopping, and buy small parts or components or segments, then you have to assemble it yourself. Some companies, they make electric fans this way also. Electric fan, you buy it in parts, components, then you can assemble that. So it's easy to market and easy to produce at the same time. It will also improve the ability to satisfy customer requirements. So customer, they will be more satisfied if they are buying products which has segmented components. If anything got wrong with any component, okay, then they can replace just that particular component instead of replacing the whole product. Now, computer aided design, CAD system. Most of engineers nowadays, if you want to have a sketch for your house, for your building, and so on, engineers nowadays, they are using CAD system. They use also the CAD system in manufacturing, in designing cars, designing TVs, mobiles, any products, which means using computers to design your product, your car, and prepare engineering documentation. Anything you will design it, you will document it so that you can go back to it anytime. Of course, this will help in a shorter development cycle, improved accuracy, lower cost. The accuracy here will be higher. Why? Because there is no human intervention. It's computers who is doing the work. That's why it will be more efficient. That's why we said here lower cost, and the accuracy will be high. So the quality at the end will be also high. We should know that information and designs can be developed worldwide. So the information that with regard to any design, it can be spread also worldwide. A lot of engineers or companies can benefit from that, and you yourself as a company, you can go back to your information anytime you want, and you can modify things instead of starting from scratch. Again, to extend the information technology, we have also what we call the CAM, computer aided manufacturing. Of course, the most important benefit that it will utilize specialized computers and programs to control manufacturing equipment. So CAM is an extension of the CAD. I mean to say that if you are planning to use CAM, so you have to take that into consideration in the design stage in the CAD system when you do the computer aided design. Now, as you see here, often driven by the CAD. It means that the CAM and the CAD, they are integrated with each other, and it should be taken into consideration during the CAD stage. Now, benefits of CAD and CAM. First of all, you will have a higher quality, better quality, because you are using computers. So the human intervention, human mistakes will be less. And as we said a while ago, accuracy is high. Shorter design time, more efficient. Production cost reduction, also efficiency. Database availability, you can, as we said, you document everything, and this database will be available anytime you need it. And of course, it will give the company new range of capabilities, because the company that have the abilities to use information technology like CAM and CAD and CAM, it will add to their capabilities, which will lead to a core competences in terms of information technology, and this of course will help the company to attain a competitive advantage. Value analysis, which is the fifth issue, focuses on design improvement during the production process when it is clear the new product is a success. So we will use value analysis when our product is still in the introduction stage, and we are sure now when we introduce our product initially to the market that it is successful. So we can use value analysis in order to restructure our process, let's say our operations, in order to make it more effective and efficient by using what we call a value analysis. Okay, and value analysis will be always related to a value chain analysis, which means that you have to look back to your operations and you will try to discover the value added activities and the non-value added activities. And of course, remember that value added activities has a cost. Non-value added activities also has a cost. So you have to terminate the non-value added activities. Example, one environmentally friendly approach to product design is to use lighter components, like the example of Nokia. You know, the furniture of Nokia are very light, so you can, you just can buy your things like you are making the normal shopping, okay? Or for example, less energy. We can see nowadays, for example, the car. Now cars with electric cars, it needs less energy. We can most of the company now, they are trying to use value chain analysis or value analysis in order to reduce energy. For example, lamps that we are using at our homes, or lamps that department stores are using, and so on. Product development continuum. Of course, any company who wants to sustain their competitive advantage, they should go to always, or think always, of continuous product development. Why? Because product life cycle are becoming shorter. Now we know, like in the mobile industry, now for Samsung, for iPhone, as you can see, and even laptops, you see the product life cycle is very short now, because technology is changing very fast. So companies, okay, or organizations should always think of new product in order to satisfy wants and needs. Of course, those wants and needs are always changing, okay? Developing new products faster than, as I said, or faster, can result in a competitive advantage. And you know that Nokia, they were late in developing new products, which is of course with the new technology at the time, which is the smartphone. Then they were left behind, they lost their competitive advantage, unlike Samsung and Samsung and iPhone. They have advanced, okay, they have advanced Nokia. Why? Because they use what we call the product development continuum. And also we have to know that it is very important for us to know what is time-based competition, which means that rapidly developing products and moving them to the market is part of time-based competition, which means it's not enough only to produce new product. It should be on time. You should be the first always, and trying to be comparing to your competitors. You always have to develop new products and launch it, okay, or bring it to the market or move it to the market before your competitors. And this is what iPhone and Samsung are doing when they produce almost the same generation of the mobiles. Each of them, when they have a new model, they will try to offer it first in order to have more revenues and more sales, and then of course more competitive, or let's say a stronger competitive advantage. Also, we have to think of the external development strategies and the internal development strategies for products. It's now some companies, they select external development strategies. The others, they select internal development strategies in order to produce new products or to develop new products. We have actually 3 external development strategy: alliances, we will talk about it in the next slide; joint venture; purchase technology or experts by acquiring the developer. And we have 3 internal developing strategies, as we can see here. The first one is migration of existing products, termination of existing or current products if you want to, enhancement or improvement to existing products, and of course new internally developed products, which means to develop a new products, not improving or migration of the present or the current products. But you have to take note here. This is a very important note, okay, that the highest risk strategy is the new internally developed products. It has the highest risk among the internal development strategies and also among the external development strategies. That's why I have it for you here in red color. So take note of it, please. Now, in general, there are three important elements, which is cost, speed, and risk. Now, let's start with the external development strategies. Now, cost in the external, if you use external development strategies, then the cost will be shared. Why? Because you have other partners, you have alliances, strategic alliances. They will share risk with you as a company. And also the speed will be faster, because if you will take the experience of the others, then they will help you to develop new products faster. At the same time, also the risk, you will not take the risk alone as a company. You are joining somebody else. That's why the risk will be shared. Unlike if we'll take it on the other side, for the internal development strategies, cost will be internal. That means that the company by itself, it will take the cost, the total cost. Nobody will share the cost with the company, and the speed will be very lengthy. Okay, it will take long time to develop product, because you are not benefiting from any outside technology or expertise or consultants or partners. And at the same time, the risk in the case of the internal development strategies will be high. Okay, now let's discuss the three external strategies. Okay, try to take some important points on each of them. The first one is purchasing technology by acquiring a firm. Means that you will buy technology, okay, from other companies. It will speed, of course. What are the advantages? It will speed your development, your product development. At the same time, all of the issues concern the fit between the acquired organization and product and the host. It means you as a host, okay, you should fit with the other organization. Like when we see, for example, a lot of company, they are buying the technology from the others. A lot of TV makers, for example, they don't really produce the screen itself, but they let other companies to do it for them. So in this way, they are buying the technology of the others. Even some, let's say, cars also, car manufacturing. Some companies in the car manufacturing, they buy technology from other companies, okay, in order to make it faster. The engine, for example, some of the companies, they don't make it themselves, they outsource that, or they buy the technology needed to do that. Okay, also we have another external development strategy, which is the joint venture. And joint venture, you know that two companies will make a joint venture together. We have Sony Ericsson as a joint venture companies, for example. Okay, a lot of local companies will make a joint venture, sometimes with foreign countries, with foreign companies, sorry. Okay, or a lot of many companies let's say a host country, they will also make joint venture with international companies. It's there are a lot of examples on that. What is the advantages? The advantage is that the most important benefit or advantage, both organizations will learn. They will learn from each other, okay, because both of them, they have different technology, different knowledgeable workers, knowledgeable management. That's why they will share it. Then of course both of them, they will learn and they will benefit from that. And of course they will share risk. So instead of one of them will take the risk, okay, they will take it as share, which of course, if the risk will be high, then it will be less for each of them. Also the third, let's say, or the second external development strategy is to do it, or the third one I think, to do it through alliances. Okay, alliances means, for example, to have a long-term partnership with your suppliers. Partnership, long-term partnership with your suppliers. This is a kind of strategic alliances. It will help. It will be very useful when technology is developing, and of course it will develop again, or reduce, sorry, risks. Why? Because risk again will be shared between you and your strategic alliance. Now, to have a note, maybe you can write it down, that alliances is more related always to supplies. I mean, companies who want to use this strategy as strategic alliances, what they do is, most of them, they do it with their suppliers. That's why they will have a long-term contract, okay, a long-term partnership, of course, through contracts with their suppliers. Defining a product is very important step. If you still remember, at the start of this chapter 5, one time I told you that there are three main steps or core steps, which is selection of your product, number one. Second, defining your product. And the third one is designing the product. Okay, again, I will repeat them again. Selection, define the product, or defining the product, then design the product. And at that time, I gave you an example about a sports car. Of course, this is last meeting, if you remember. First definition is in terms of function. For example, when I will define a sports car, yani extending our example, what are the functions that I will care about? The function of speed, for example, the function of safety, and so on. Also, rigorous or detailed specifications are developed during the design phase. Okay, in the design phase, we will talk about details. In the third, not in the defining stage, not in the selection stage, but in the third stage, which is the designing stage, we will talk about more detailed specification of the sport car, for example, or any other product. Manufactured products will have an engineering drawing. I will talk about it in the next slide to know what is engineering drawing. In the next slide, we will know what is a bill of material. You will see now. And on the third, on the next slides, we will talk about make or buy decision, which means which is cheaper for the company, or which one is cheaper for the company, is to make the product or to buy the product. Okay, we will talk about it also on the next coming slides, but let's first talk about the engineering drawing. What is engineering drawing? It shows dimensions, tolerance, materials, and finishes of a component. It will also, this is important, shows for group technology. Now we can go back forward to this slide, and then we will go back to the next to explain the bill of material. As you can see here, this is an example of engineering drawing. As you can see, when we talk about tolerance in the previous slide, we mean like for some machines they have fractional, for example, fractions. It is 1 over plus or minus 1 over 64. In decimal 4, it is equal to plus or minus 0.005. I mean, I don't want you to memorize what is inside this figure. No, I'm just giving an example. What does it mean, engineering drawings for our products, just to see. Okay, I need only the definition in the previous slide, but I want you to see a sample of an engineering drawing. And also, when we talk about a group of technology, for example, this material, this kind of material, it is from the family A, okay, or group A. That's why we said grouping technology into A, B, C. Similar parts, we will talk about it also later on. Similar parts will be under one group or one family, the A family of parts, the B family of parts. Like for example in the car, everything is related to electricity in the engine. It will be under, let's say, the C family. Okay, so we know that this part will be let's say from the C family, which is electricity. It will be of course defined. It's up to you to name it as you wish. Okay, now going back to our slide again, to talk about the definition of bill of material or bills of material. It's a list of the component, their description, and the quantity of each required to make one unit of the product. It will show also product structure. Let's see an example on the next. Here you have here one example. Okay, it's about the weldment, panel of weldment. You see the number of here what we were talking about, grouping technology. Okay, this material is A, codes A, R, P, A, whatever. These are the grouping technology or the families of the parts. This is the description, like panel weldment, for example. The quantity needed to make one product is 1, and so on. We have an easier example for you, maybe another example for bill of material, and I prefer this for the student, about hard rock. Okay, hard rock cafes, of course. We have an example here, a bill of material to make only 1 unit of barbecue bacon cheeseburger. Okay, a barbecue cheeseburger, to make only 1 unit, 1 sandwich, يعني سندويشة واحدة. You need these what we call bill of material. All of these material in order to make only 1 cheeseburger. Okay, this is the description as an example, and here we have the quantity. For example, you need one bread, 1 pan. Okay, 1 slice. Quantity is 1. Hamburger patty, you need 8 ounces. Cheddar cheese, you need 2 slices for 1 burger. Bacon, for example, you need 2 stripes. Okay, barbecue onions, you need barbecue onions, you need 1/2 cup, let's say. Sauce here, barbecue sauce, you need 1 ounce. Leches, this is the burger set, of course. 1 leaf, tomato, 1 slice, red onion, and so on. So as you can see, this one as a whole, we call it a bill of material, which means the materials, their descriptions, their quantity, in order to make 1 unit of the product. And this is a very good and easy example. Now, before we take this slide, by the way, 39, this slide should be 40, and slide 40 should be 39. Yani this slide will be a 39. This is what I talked about a while ago, group technology benefits. Group technology, when we talk about the families, okay, enables the grouping of parts into families, like we will say the A, the R, as I told you, the example of the, let's say, electric wiring in the engine, maybe it's C, okay, D, as you said, but it will be, you will group your parts with accordance to technology under families, A, B, C, whatever, based on similar processing requirements. Like we said, all parts related to electricity will be under 1 family, which is A, which is B, or C, whatever. Now let's go. This is slide 40, and this should be, okay, the other one, 39, and this one should be slide 40, the make or buy decision. Of course, next meeting we will, our next lecture, let's say, next video or lecture, we will talk about the make or buy decision. Sometimes the company had to need to take a decision, if do I have to buy this raw material or I will make it, I will produce it. Okay, this is the question. Do I have to produce, مثلا, for example, if you are a textile, okay, or a clothes manufacturing company, then you will think, do I buy the textile or I make the textile? Okay, so we will help you through quantitative method next meeting, this next lecture, when we start with slide 41, we will talk about it. We will see which is, we will take examples, and we will know how companies, or how manufacturing companies, they take a decision, or what we call the make or buy decision, okay, to buy the raw material, or to make or to produce the raw material. And of course you cannot answer that unless you will make calculations and you will take into consideration both alternative. Then you will evaluate each of them quantitatively, then you will take your decision. We will continue with that. Okay, here I will show you next lecture. We will start with chapter 41 to continue with the application of the decision tree, اللي هي make or buy decision, to product design, and we will take examples on that. Thank you very much. I hope you will see this video and you are all fine, وبتمنى للجميع السلامة دائما. Thank you very much.